Hi everyone in Algebra 2B. Today we're going to be going over questions on 103B, and it looks like there's a lot of questions on this lesson. So if you need to scroll through the video to find your question that's being asked, please make sure you're doing that. Just a reminder that you guys do have your second half of your test tomorrow, so make sure you check around web for the information on that and your email for the actual test that will come out. Okay, so for number 16, the first thing that we're going to do is we want to add the top two equations together and eliminate one of the letters. And what I'm going to do is I'm going to actually add the top two, and I'm going to multiply the top one by -1. That would give me negative x minus 2y minus z equals positive 1. My middle equation I'm going to leave the same at 3x minus y plus z is equal to 6. So when I do that, I'm actually eliminating the z. And when I add that together, I'm going to get 2x minus 3y equals 7. Now for the bottom two equations, when I add those together, the z's actually eliminate by just adding them together. So I would get 5x minus 4y equals 14. Now I'm trying to add these two equations together, and you can do that by either substitution or elimination. It doesn't matter which one. I'm going to choose to just do elimination. So I'm going to multiply, well, let's eliminate the x. So I'm going to multiply this equation by -5 and then this equation by 2. When I do that, I'm going to get 10x minus 8y equals 28. And when I multiply that by -5, I get negative 10x plus 15y equals negative 35. And I'm going to use my calculator just so I don't mess up. So 8 minus 15 would give me negative, or 7y equals, and then 28 minus 35 would give us -7. So -7. The x's cancel, so y is going to be equal to -1. Now, once I know that, I'm going to plug it into this equation here. So that would be 2x minus 3 times -1 equals 7. So 2x plus 3 equals 7. Subtract 3, and that would give me 2x is equal to 4. And therefore, x is equal to 2. My last step is just to solve for z, and I'm going to do that by plugging it into the top equation. So for x, I have 2 plus 2 times y, which is -1, plus z equals -1. Well, 2, and this would become -2, so that actually cancels. So my result is z is equal to -1, and that would be my answer. So x is 2, y is -1, and z is -1. Now moving on to number 17. So for number 17, the first thing that I'm going to do is I'm actually going to evaluate this equation for y. So I have -4y is less than or equal to -x minus 4. I'm going to divide everything by -4, but remember, when you divide by a negative, the sign is going to change. So this becomes y is greater than or equal to 1 over 4x plus 1. Which means that we're going to have a solid line here because of the equal sign, and we're going to shade everything above that line. Now, so this is going to cross at +1. The slope's going to be up 1 over 4, or down 1 to the left 4. And again, that's going to be a solid line, so we can just draw a line that's like that. And then for this one, x is less than 3. Well, 3 is right here. That's going to be a dotted line because it does not have an equal sign under it. And this one, we're going to shade everything to the left of that dotted line. So now what I'm going to do is I'm going to do my shading process. So everything above my solid line would be everything up here. And then everything to the left of the dotted line would be everything over here. And your result is going to be this right here. Everything above the diagonal line and to the left of the dotted line. And that is your result for number 17. Now moving on to number 18. So the first thing that I'm going to do here is actually going to separate out this inequality. So I'm going to have -3 is less than or equal to x minus 3. And then I'm going to have x minus 3 is not greater than or equal to 4. My domain is integer, so that's going to be points, not a point with an arrow. I'm going to start by evaluating this left one for x. So I'm going to add 3. So 0 is less than or equal to x, but I do want to flip it so that the x is on the other side. So everything about this equation is just going to flip. So that becomes x is greater than or equal to 0. Now I see this inequality has a slash through it, which means I need to flip it and take away the equal sign. So that's going to be x minus 3 is less than 4. Move the 3 to the other side, gives me x is less than 7. So on my number line, I have -2, -1, 0. So that's 1, 2, 3, 4. That's my number line. Now, if it's going to be greater than or equal to 0, that means it can be equal to 0. It cannot be equal to 7, so I would leave that 7 open. And it's going to be less than 7, so to the left of 7, and greater than 0, so to the right of 0. So that means I'm going to connect my two endpoints and fill them in with all filled in dots. And that would be your result for number 18. For number 19, the first thing that I'm going to do is I'm going to distribute this b into the exponent and bring this denominator up to the numerator. So this would be x to the 2ab, and then -2b, and x to the -b over 2. Now you'll notice that your bases are the same, so we can add the exponents together. So I would have 2ab minus 2b minus b over 2. Now the thing that I could combine are these two variables right here by making a common denominator, multiplying top and bottom by 2. So that would be -4 minus b. So my answer is going to be x to the 2ab. -4 minus 1 would be -5b over 2. So all I did was I added the 2b and the b over 2 in the exponent by making a common denominator. Now for number 20, I'm going to start in the denominator by making a common denominator with these two fractions. The common denominator is going to be m, so I'm going to multiply top and bottom by m. Everything else is going to stay exactly as is. I'm going to have m over m squared plus m over, and this would turn into m cubed plus 1 over m. Now I'm going to multiply this denominator by this numerator. Everything else is going to stay the same. So that would be m over m squared plus, that would also turn into m squared, and it would be over m cubed plus 1. We need to add these two fractions that are in the denominator by making a common denominator of m cubed plus 1. So I'm going to multiply this right here by m cubed plus 1. The m in the numerator is going to stay the same. When I multiply this m squared times 1, that would turn into m to the 5th plus m squared plus m squared all over m cubed plus 1. You're going to end up multiplying the m cubed plus 1 times the numerator. And I can combine the two m squareds in the denominator. So that would turn into m times m cubed plus 1 over m to the 5th plus 2m squared. But notice that there's an m in every single term that we could actually simplify by. So that means my numerator would turn into just m cubed plus 1. My denominator would turn into m to the 4th plus 2m, and that would be my result. You can't go any simpler because of this plus 1 that's right there. Now moving on to number 21. So for number 21, I'm going to start by changing this into exponential form instead of in this format. So this would turn into x squared y to the 3rd all to the 1/5. This would turn into xy all to the 1/4. We're going to distribute that, so that would be x to the 2/5, y to the 3/5, x to the 1/4, y to the 1/4. Now you're just adding fractions. So this would be x to the 2/5 plus 1/4, and then y to the 3/5 plus 1/4. That would all just take making a common denominator. So multiplying this by 4/4 and 5/5. Same with this one, 4/4 and 5/5. So 8 plus 5 would be 13/20. And then for my y, this would be 12 plus 5, which would be 17/20. And that would be your result for number 21. Now for number 22, before I can get started, I need to simplify. So my I squared is going to be equal to -1, and my I cubed is equal to -I. So really what I have is -2 minus I over -I plus 2. So when I multiply this out, I'm going to multiply this by -I minus 2 on top and bottom. So -2 times -I would be positive 2I. -2 times -2 is positive 4. -I times -I would be positive I squared, and I squared is equal to -1. And -I times -2 would be positive 2I. Now in my denominator, I have -I times -I, which would again be positive I squared, but I squared is equal to -1. -I times -2 would be 2I. 2I times -I would be -2I, and then 2 times -2 would be -4. So my 2i's are going to cancel. Then I have 2i plus 2i, which would be 4i. 4 minus 1 would be 3, and that's all going to be over -5. And I think they would distribute that negative sign into the numerator and make it -4i minus 3 all over 5. Now looking at number 23, I'm also going to change my I squared to -1. So that means that I get 2i minus 5 over -5 minus 2i. Meaning that when I multiply by the conjugate, I'm going to multiply by -2 plus, or -5 plus 2i on top and bottom. So 2i times -5 would be -10i. 2i times 2i would be 4i squared. I squared is equal to -1. -5 times -5 is 25. And then -5 times 2i would be -10i. Over -5 times -5 would be 25. -5 times 2i would be -10i. -2i times -5 would be plus 10i. And then -2i times positive 2i would be -4 times -1. And then what I'm going to get is the 10's going to cancel. In the numerator, I would end up with negative 20i, and then 25 minus 4 would be plus 21, over 25 plus 5 would be over 30. And I think in the answer key, what they're going to do is they're going to separate that as 21 over 30 minus 20 over 30i. So I could simplify the first part by 7. So it would be, or by 3, sorry, would be 7 over 10 minus 2 over 3i. So they just separated out the two numerators with the denominator. Now lastly, number 24, the square root of 20 can simplify to 2 root 5. So this is actually going to be 3 plus 2 root 5 over 5 minus 2 root 5. So I'm going to multiply top and bottom by 5 plus 2 root 5 on top and bottom. Multiply this through. So 3 times 5 is going to give us 15. 3 times 2 root 5 would give us 6 root 5. 2 root 5 times 5 would give us 10 root 5. 2 root 5 times 2 root 5 would be 4 times 5 over 5 times 5 is 25. 5 times 2 root 5 would be 10 root 5. Negative 2 root 5 times 5 would be negative 10 root 5. Negative 2 root 5 times positive 2 root 5 would be negative 4 times 5. So the 10 root 5s would cancel. In the numerator, I have 4 times 5, which is 20, plus 15 would be 35, plus 16 root 5. In the denominator, I have 25 minus 20, which would just be 5. You could leave your answer like this. I would accept that, but I think in the answer key, again, they separate that as 35 over 5 plus 16 root 5 over 5. Moving on to number 25, the first thing that I'm going to recognize is that this 4 is going up 4 spaces. It's not going left or right. So I get 0.00r plus 4.00u. For this one over here, it's going to the left of the origin and it's coming down off the x-axis. So to solve for x, I'm going to do 6 times cosine of 29. And for y, I'm going to do 6 times sine of 29. So 6 times 29 cosine equals, and I get 5.25. Then 6 times 29 sine equals, and that would be 2.91. So now my x is going to be negative, so it's going to be negative 5.25r. My u is also negative, so it'll be negative 2.91u. When I add the r's together, I'm going to get negative 5.25r. When I subtract, it would be 4 minus 2.91, and I would get plus 1.09u. So using cosine and sine to solve for r and u. Now for number 26, the first thing that I'm going to do is I'm going to distribute the a, and then I'm going to eliminate the denominator. So when I distribute the a, I'm going to get ab over c minus a over x equals m over p. To eliminate the denominator, I'm going to multiply the whole thing by cxp, which means I would multiply this first fraction by px, so it would be abpx. Second fraction, I would multiply by just the c and p, so it would be acp. Last fraction, I would multiply by the c and the x, so it would be cmx. Now we're solving for x, so I'm going to move the ACP to the right, the CMX to the left. So I have a b px minus cmx equals ACP. Now if I factor out the x on the left-hand side, I'm left with ABP minus CM. Right side stays the same at ACP. Now to get x by itself, all you do is divide. So I have ACP divided by the parentheses, which is ABP minus CM. And that would be your result for number 26. Now looking at number 27, the first thing that I'm going to do is I'm going to move the root z to the other side by subtracting it. And I'm going to square both sides. So when I square z plus 33, the square root of z plus 33, I would just get z plus 33. When I square the 11 root z, or 11 minus root z, I actually have to multiply it out. So the left is going to become z plus 33. The right, 11 times 11 is 121. 11 times negative root z would be negative 11 root z. Negative root z times 11 would be negative 11 root z. And negative root z times negative root z would just be z. So the z's on both sides would cancel. And when I add these together, I get negative 22 root z. But I want to bring it over to the left-hand side. So that would be positive 22 root z equals 121 minus 33, which gives me 88. When I divide both sides by 22, I'm going to get the square root of z is equal to 4, which means that z after squaring both sides is going to be equal to 16. You do need to check your answer, meaning to plug it back into the beginning to make sure that it works. So the square root of 16 plus the square root of 16 plus 33 equals 11. The square root of 16 is 4, and 16 plus 36 is the square root of 49. So does 4 plus 7 equal 11? Yes. So my answer is z is equal to 16. Now looking at number 28, before I can even get started, I need to recognize that the square root of 4 is actually just equal to 2. And then I need to get rid of the square root of 3 in the denominator and simplify the square root of 48. So 2 and 24, 2 and 12, 2 and 6, and then 2 and 3. So that means there's 2 pairs of 2's. So I get 6 root 3 over 3 minus 2 root 3 over 2 plus 5 times 2 times 2 root 3. Now the 3 goes into 6 2 times, 2 goes into 2 1 time. So I really have 2 root 3 minus root 3 plus 20 root 3. And that would give me a result of 21 square root 3. So if you did not recognize that the square root of 4 could be simplified, that you could have just kept on going the same way you usually do, but your answer in the end would have just needed to be simplified. Now number 29, the square root of negative 16 is actually going to give us 4i, because the square root of 16 is 4, because the negative sign it's I. Then I have square root of 2 times square root of 2 would become 2i. And I'm going to multiply that by square root of 3 times square root of 3, which would be 3i squared. I to the 5th, 1, 2, 3, 4, 5 is actually just equal to I. So now I have 4i, and I have 2i times 3i cubed would be 6i cubed minus I. I to the third is just equal to negative I. So I have 4I minus 6 times negative I minus I. So 4I plus 6I and then minus I. 4 plus 6 is 10, minus I is 9. Okay, and then lastly for number 30, they give us this triangle ABC, and we're trying to find this measure of this angle right here. I know that AB and AC are equal to each other, and I know that this angle is 40. That means that angle B and angle C are going to be equal to each other. And the way I'm going to solve for that is I'm going to do 180 minus the 40 degrees and then divide that by 2. Because 180 minus this angle and then what's left would be these two angles and they're equal to each other. So 140 divided by 2 gives us 70. Which means that this angle here is 70 degrees. This angle here is 90 degrees. And if you see this small little triangle right here, I would have angle B plus my 90 degrees plus my 70 degrees equals 180 degrees. So my angle B is going to be equal to 20 degrees. And they write it as angle DBC, so your answer would be 20 for number 30. That should conclude all your questions on lesson 103B. Don't forget to watch your lesson 104 and also to post all your questions for 104A in the comments of the 104 video. Hope you guys all have a great day. Bye.